Hello everyone, welcome to the channel. In this video, let's gonna learn about elementary row or column operations and also about the rank of the matrix. This elementary row and column operations helps in the operating of the matrix given. Suppose if a matrix is given like this, A is equals to something like this. 1 2 3 4 5 6 7 8 9. So operating this matrix will be easy using this elementary row or column operations method. In this elementary row or column operations method, we have some specific basic row operations and column operations. I'll show you now below. This row operations, first of all, row operations of a matrix. Suppose in this matrix, already I have told you in the last video, these are called as rows and these are called as columns. These rows, now in row operations of the matrix, we use only rows to operate any matrix. Example, I'll show you it. We have some this row, take it as row 1, take this row as row 2, take this row as row 3, something like R1, R2, R3. So these row operations are made only about the rows of the matrix. Something like this. We have some conditions to operate on these rows. I'll show you. Ri, it is any of the row of the matrix of a given matrix can be interchanged with any row of the matrix. A row of the matrix can be interchanged with any row of the matrix of a given matrix, which can be any row or any column. This can be interchanged. And now case 2. Any row of the matrix can be multiplied with any constant. K is constant. These operations are mainly made to form a new matrix. In third case, third case is a very important, in which we operate two rows. Something like this. Ri gives rise to 2Ri minus Rj. Something like this. This is a main part of the operations of the matrix, which are mainly used in the further coming topics in the matrices. This is all about the column operations of the matrices. This column operations of the matrices specifiedly made only for row operations. These row operations are only specified for only rows, interchanging or changing the values of the rows, or changing the value of the elements in the rows. These operations are made only for rows, and we have separate concept for the columns also. And in this specifically, this cases are mainly important. This first 1 to 3 cases are mainly used in the simplification of any matrices, or converting any matrices to a given form. These 3 cases are mainly used, and where this k is a constant and this k should not be equals to 0. It is main point to be noted. This is a main point. Now let's continue with the column operations. Here also let's gonna take an example of the matrices for the better understanding. 1 2 3 4 5 6 7 8 9. So already I have said you, these are called as columns. Let's take this as column 1, column 2, column 3. This column operations or the row operations are the basic form of conversion of the matrices. I'll show you it. And which column and this column operations have some specific cases. They are just similar like row operations. I'll show you. Column operations. Case 1. Similar to row operations, any column can be interchanged with any column of a given matrix. Can be interchanged. Any column can be multiplied with any sort of constant. Any column can be operated with any with any column of the matrices of a given matrix, where here this k should not be equals to 0 because this constant should not be equals to 0. Here this operation can be made according to our wish, or according to the model we want it to be converted, according to our flexibility in the problem. This third case can be converted according to the comfortable of a person during the solving of a problem. And this is a main part of the and very easiest part of the matrices operations. And now let's learn about the main head of this matrices, the rank of a matrix. There are many methods to find this rank of a matrix. Let's discuss today about one of the method of finding this rank of the matrix, which is known as echelon form of matrix. This is one of the method to find the rank of the matrix, which has certain conditions. A matrix can be converted into echelon form of matrix with certain conditions. I'll now explain you what are these conditions. First condition is 0 rows, if any, must be after all non-zero rows. This point means the 0 rows which are in the matrix, in a given matrix, should be after all the non-zero rows. Example makes you understand clearly. If suppose A is a matrix and which is like this: 1 2 3 0 0 0 4 3 1. In this case, first row and third row are non-zero rows. This second row is zero row. This statement means if any zero rows are present, there must be present at the end of the matrix rows. It means in the last row this zero rows must be present, something like this. B is equals to, let's change this upper matrix into the certain condition matrix. This doesn't obeys the first case. This second matrix obeys the first case, as this non-zero rows are kept up and all the zero rows, if they are present, they are settled at the end of the matrix. So this second matrix is a curved form of, and which obeys the first condition of the echelon form. And now here comes the second condition of the echelon form of a matrix. The first non-zero entry in each non-zero row must be 1. This statement means, example, if we have a matrix, the first non-zero entry in each non-zero row must be 1. Let's take some non-zero rows as 1, 2, 3, 0, 1, 2 and 0, 0, 1. In this case, if consider row 1, in this row 1, the first non-zero entry is 1, and this in this row 2, the first non-zero entry is 1, and this row 3, the first non-zero entry is 1. The statement means in an echelon form of matrix, the matrix should have first non-zero row must contain 1 value. The element must contain the value 1. This condition is as simple as possible and as easy as understandable. And next, let's go with the third case of echelon form of matrices. This case 3 tells that the non-zero entry must be increasing. The non-zero entry must be increasing. This small statement means a lot. I'll clear you out with describing this statement. If the number of zeros before the first non-zero entry must be in increasing order. This point is very, very important, and this case is also very important because this case makes a person feel difficult and get confused. I'll show you with an example. If A is a matrix, 0, 1, 2, 3, 0, 0, 1, 2, 0, 0, 0, 1. In this matrix, the number of zeros are increasing. It means the number of zeros before the first entry of non-zero matrix should be increasing. Something like in first row we have 1 0. In second row we have 2 zeros. In third row we have 3 zeros. It means in our simple words, the zeros must be increasing from top to bottom. This top to bottom, the zeros must be increasing. The zeros must be increasing if the zeros which are present before the first non-zero entry, obviously the first non-zero entry in echelon form is 1, so the zeros before the non-zero entry must be increasing order from top to bottom of matrix. If matrix is written like this from top to bottom, this zeros must be increasing. Then only we say this matrix is in echelon form. If the matrix obeys all the first, second and third cases, then the matrix is said to be in the form of echelon form. Behalf of learning all these cases, now let's have a trial on the problems through which we can be more clarity on the concept that we have learned. Now we have learned all the concept to find the rank of a matrix. Behalf of all this, how to find a rank? It's a big question mark. So this is a simple and easy. We have a trick called in echelon. If finally by using all the operations, we've we've we reduce a given matrix into echelon matrix. So in that echelon matrix, the rank can be found by the number of non 0 rows present in echelon form. Rank. This is very, very important point to be noted, which helps in finding the rank of a matrix. Now presently we are using an echelon form of matrix. So in the echelon form of matrix, rank can be found by counting the number of non-zero rows present in the echelon form. Now let's have a trial on the problems based on this all the concept which we have learned. Now let's go with the problems of the matrices using echelon form. And this is a given matrix. This should be converted into echelon form. And also after conversion to the echelon form, we need to find the rank of the matrix. So let's have a detailed solution of it. Now A is equals to. So this, I feel this first row which is obeying the echelon format, because this first non-zero element is 1. 3 2 3 2 1 3 6 8 7 5. This can be interchanged, not interchanged, but this can be reduced. R2 can be reduced. R3 also can be reduced. R4 also can be reduced. R2 can be reduced as, let's take the help of this R1 row. As we know, this is row 1, row 2, row 3, row 4. So now to find row 2, let's take the help of row 1, because I feel that the row 1 is identical and it's perfect. And this row 2 is equals to R2 minus 2R1. And next, let's operate this row 3. Row R3 is equals to R3 minus 3R1. And now it comes to R4. R4 tends to R4 minus 4R1. Based on all these three operations, the next matrix can be written, which is known as reduced form of matrix. A is equals to, now this row 1 is as it is, 1 2 3 0, and this row 2 is changed into R2 minus 2R1. What is R2? 2. 2 minus 2 into R1. 2 into 1 is equals to 0. Here in the first place we got 0. We're happy to know that, because which is in the process of converting to the echelon form. And next, 4. 4 minus 2 into 2. 4. 4 minus 4, 0. And 3. 3 minus 3 into 2, which means 2 into R1, minus 6, which is given as minus 3. 2 minus 3 minus 2R1. Okay, here we get 2. And next, here goes with R3. We have for all the corresponding simplification, we got an equivalent, not an equivalent, but a step of matrix, in which this, I feel, this row can be interchanged. I mean R4 can be interchanged with R2, and through which can become more simple. 1 2 3 0, and R2 is in R4 is interchanged in R2. 0 minus 4 minus 7 5, and next 0 minus 4 minus 8 3 0 0 minus 3 2. And from this, now we need to mainly operate with this 2, because here first row is completely okay and second row is also okay, and this can also be interchanged. This R3 can be interchanged with R4. The equivalent matrix is written like this: 1 2 3 0 0 minus 4 minus 11 5 0 0 minus 3 2 0 minus 4 minus 8 3. So in this matrix, now that should become more simple. And now this R4 can be changed like this. R4 can be changed into R4 minus R2. 1 2 3 0 0 minus 4 minus 11 5 0 0 minus 3 2. R4 can be changed as R4 minus R2. R4 is 0 0 minus 0 0 minus 4 R4 minus of R2. R2 is minus 4 plus 4, and here we get 0, and R4 minus R2 means minus 8 plus 11. Now we get 3, and now we get 3, and next here 3 minus 5 we get minus 2. This is all about the simplified matrix, and this R4 can be changed as R4 is equals to R3 plus R4. This I'll show you here. If A is the matrix 1 2 3 0 0 minus 4 minus 11 5 0 0 minus 3 2, and next R4 is changed as R3 plus R4 now. So now R3 plus R4, 0 plus 0 0 0 plus 0 0 minus 3 plus 3 0 and 0. Unfortunately, all this row became a 0 row. This can be considerable. Then now we have a small trick to find a simplified equivalent form. Now in this matrix, we have 0 rows which are located at the below of the matrix, and we have we have this one digits, but not for all. That second case must be kept aside for some time, and this is quite increasing. This is quite increasing order, but not strictly, but it's quite increasing order of non-zero entry. See, here we can find only 1 0, 2 zeros, and here 4 zeros. So first condition and second condition are satisfied. First condition is non-zero entries must be before the zero entries, and second is we should have the value 1 in the first non-zero entry. Let's make it value 1 at the non-zero entry like this. Now let's take R2 is equals to R2 by 4, R3 is equals to R3 by 4, R4 is as it is R4. Now we get answer. So A is equals to 1 2 3 0 0. R2 by 4, R2 is minus 4, and by 4 is equals to minus 1. And next we have this and behalf of this, and so we are getting -1. So here unfortunately in the default we can have minus symbol over here also, then this becomes +1. So here also we have R2 by 4, which means 11 by 4, which means 5 by 4. And next R3, 0, 0, and -3 by -3, -3 by -3, which will get 1, and 2 by -3. So here is all 0 entries. So from this matrix, we can say that this equivalent matrix is an echelon form of matrix, because the first non-zero entry in every row is 1. In every row is 1, and all so the first the first case is cleared, and the second case is it should be in the increasing order. The 0 entries must be in the increasing order from top to bottom. It is also okay now. And coming to the next one, this row, this 0 row must be below of all the non-zero rows of the entries. So according to this, all the three cases are clearly accepted by this matrix. So now to find the rank of the matrix, already we have discussed that the rank of the matrix is equals to number of non-zero row in a matrix. So here number of non-zero row, how many we have in this? So 1, 2, 3. This is a 0 row. So we have three non-zero rows. So then the rank is 3. Hence, the rank is found like this. This is simple. This is not just complicated, but a trick which has to be understood easily. And this is all about today's class. And let's meet having another topic in the next session. Then signing off. Thank you, and please do like, share, and subscribe my channel, and please support my channel, and even let me know the topics which you want to be explained by me through a comment section. Have a comment in a comment section and let me know the topics which you want to get explained. And I wish you like this video, and I'm ending it. Thank you.